Hi! So now that we know how to train a single neuron, all we need to do is generalize this information on different neural network types. Just as before, we will start by learning how to train a neural network with several inputs and one output. Then we will try to do this with several outputs and etc. until we are able to train a real life, real deep neural network. So without further ado, let's go ahead and get started. First of all, I will import NumPy because it will be useful for us in the future. I will define INN just as before, except that remember that for an INN with multiple inputs, we needed to calculate a dot product that calculated the weighted sum of all the inputs to calculate the output prediction. So I define this right away. Then I'm going to define our data. Again, nothing new. You can remember all of this from the previous videos. I have features for predicting our movies, IMDb rating, Rotten Tomatoes rating, and number of positive reviews. This time I will add target prediction because before we were just trying to predict anything random based on the weights that we have, but now that we have a target prediction we want to train to, we will need this information as well. Also, instead of a regular array, I will use a NumPy array for the inputs and for the weights. You will see in a minute why it will be useful. NumPy will allow us to perform some of the operations that we need to much easier and faster. So now that we have defined our data, we have everything we need to start training. So before we do so, let's actually check out what NumPy will be able to do for us. It is able to create element-wise operations between different arrays. So just to give you a quick example of the kind of thing we will do, let's define two NumPy arrays, A and B. And what it's able to do for us is, for example, do element-wise multiplication between two arrays, A multiplied by B. We will just use the multiply symbol, nothing special here, no special functions, but unlike regular arrays, which were unable to do this, NumPy will multiply each of the elements by its counterpart. It will multiply 1 by 4, 2 by 6, etc. So this will perform element-wise multiplication, which we will need in a second. It will be able to do element-wise addition for us as well, which is the second operation we will need out of NumPy in this tutorial. So if I want to type A plus 2, it will add 2 to each of the elements in the array A. 1 plus 2, 2 plus 2, and 3 plus 2. So this is what you need to understand about NumPy for now, and we will now use these operations to perform gradient descent on a neural network with multiple inputs. Okay, so the first step is going to be very familiar once more. We will calculate our prediction, we will calculate our error, and we will print them out to see the baseline prediction. So by default, with the weights assigned randomly, our neural network predicts the prediction of 50, and what we want is for it to predict the 95. So it would be like 95% probability that we want to watch a movie with these ratings. Well, so that's the starting point. And the next thing I want to show you is how to perform a single step of learning. But first I will copy and paste code from the previous tutorial to remind you how we did it in the past with only one neuron. So we used to calculate an error. Then we would calculate the derivative of this function, which is this formula. Please keep this in mind, it's going to be important. And then we have updated the weights by derivative. And sometimes we multiplied derivative by learning rate to make the steps a little bit smaller. Just to introduce a bit of new terminology, this part of the equation I'm going to be calling pure error, because it just looks at how much we have missed our target prediction. It's going to be positive if our prediction is too high, it's going to be negative if our prediction is too low. And then this part of the equation is multiplied by the inputs. So what is changed in the situation where we have multiple inputs and one output? Well, if you look at this equation, basically this number has not changed at all. Like we have, imagine a neural network with 3 neurons coming into one output. So the output prediction that it calculates is going to be our regular prediction, it's going to be just one number. And the target prediction is also just one number. So our output prediction will be 50, our target prediction will be 95, and 50 minus 95 will be minus 45. So the important thing to understand here is that no matter how many inputs we will have, this number will not change. With one input it would be around minus 45, and with a dozen of inputs it will still be the same number, because this part of the equation is identical. The part that is going to be different in this case is inputs, because now that we have 3 inputs, we will need to calculate a derivative for each of the weights. We will need to multiply this number by the corresponding input. So 3 weights, 3 inputs, and this is the only part that is going to change. Instead of multiplying it by the only one input that we have, we will multiply it by 3 inputs in order. And that will allow us to update each of the 3 weights. So our goal here is to create several derivatives for each of the weights and then update them. Again, here we used to subtract one derivative from one weight. Now we will have three weights and we will have to subtract three derivatives from them and also multiply them by learning rate. Again, learning rate will be the same as before. So let's see how it's going to work in practice on an example of taking one step of learning. So first I will define a variable learning rate. It's going to be much lower than it used to be. That is because our inputs are much higher. If you remember in the previous videos, our inputs were around between 0 and 1, but now our inputs are like 7.5, 68, 3, and 68 is a pretty big number relatively, and it is going to cause our weight updates to overshoot by too much unless we will make learning rate reasonably low. So the next part is to define this part of the equation, the pure error. Excuse me, not this one, but I will just copy and paste the code that we used to have over here. I'm not running it, it's just a reminder. So this part of the derivative we are going to call pure error, and I will just copy and paste this equation here to make it extremely clear that this is the same thing. This is what it represents. The next step is to calculate our derivatives. That's going to be pretty interesting. How would we do that? Derivatives, remember these will be the three derivatives for each of the weights that we want. And to calculate three of them, the process will be identical to calculating one of them. We will just have to repeat it 3 times. So technically we could write a for loop that loops through each of the inputs and each of the weights. So it would loop through each input and multiply the pure error by this input and put the result into array of derivatives, and then we would use it in the future. But thanks to NumPy and its element-wise multiplication, we are able to simply say inputs multiplied by error, like so. Let's look how derivatives look like. Look at that. So it automatically, instead of us writing for loop, it simply went through array of inputs, which were 3 numbers, and multiplied each of them by one number of pure error. So now we have derivatives which are pretty huge, but here they are. So that looks very, very similar to what we used to have, except that now operation is performed on an array instead of one number. Sweet. Next step, just as before, is to update our weights. But I will introduce an extra step just to make it more clear. So I will type weight updates that will represent this part of the equation in order to make it more clear. So I will type weight updates. And here what we want to do is to multiply derivatives by learning rate. Just as before, because derivatives is a NumPy array, it will all be automatically multiplied by this number, thanks to NumPy element-wise multiplication. Like so. I wanted to print out the weight updates for us to see what's going on. So we simply took these numbers and made them much smaller to make our steps much smaller. And finally, it's time to update our weights. Weights, which as you remember is an array, is a NumPy array over here. And we will subtract weight updates from them. Exactly as before, except this time we are doing the same thing, only on 3 numbers at a time. Let's see what happens. Now we have our updated weights. Wonderful. And finally, let's try doing our prediction again to see if it's going to work and improve our prediction a little bit. Again, copy pasting code, running it. Look at that. Our prediction used to be 50, now it's 71, and error used to be big and now it's much smaller. So our prediction is much closer to what we want. Wonderful. So there you go. This is one step of learning, and just as in the previous video, it's absolutely identical, except that we are doing this for three numbers instead of 1. That's literally the only difference and the only thing you need to understand from this video. Finally, let's put all of this into a for loop to repeat it automatically multiple times and see if it indeed results in the predictions that we want. For I in range, let's say 20, and I will just copy paste the code for convenience because literally nothing has changed. We have our prediction, we calculate error, we print them out to track our progress, we calculate our pure error, we calculate 3 derivatives by multiplying 3 inputs by the old pure error, and then we do weight updates, and then we update the weights by subtracting. Everything is absolutely identical. Now let's run it. The first prediction is 71 because we have run one of the steps already. Before we have already updated our weights once. Then our prediction gets closer and closer to what we want until we are finally arriving at 94.99, which is basically 95 which is exactly what we wanted. If I'm going to run it again, 20 more times, now it's practically ideal. So it's exactly 95.0, which is exactly what we wanted. And congratulations, we have trained a neural network with 3 inputs, and now we are one step closer to our goal of training the real deep neural network. Awesome. So that's it. I hope this tutorial was useful to you, and I hope you understand it well. And as long as you can follow the idea that we have done exactly the same thing but to 3 numbers at a time, you're going to be fine and you will understand everything great. So I'll see you in my future tutorials.